Hi, let's discuss in this lecture about statical determinacy and statical indeterminacy for trusses. We have discussed about this concept before when we talked about rigid bodies, and this concept would apply in the same fashion with regard to the truss when we look at a truss overall, like as a whole body. So if we regard the truss as a rigid body, then the same concept would apply as it did before for rigid bodies. So in other words, for example, if we have more external supports than necessary, than 3 for equilibrium, then the truss will be statically indeterminate. But because we looked at the truss overall, we will consider the truss being statically indeterminate externally. The other thing that may happen for a planar truss is that it could have more members than necessary for equilibrium, and then this truss would be statically indeterminate, but internally. So it could still have externally 3 reaction forces, so externally it would be statically determinate, but because there are more members than necessary within the truss, then the truss would be statically indeterminate. Now, we can only solve for statically determinate trusses, both internally and externally. So we need to make sure that the trusses that we analyze are statically determinate, again, both externally and internally. So in order to do that, we have to establish a method. In this method, of course, we need to ensure that the number of the unknowns we have to solve for is equal to the number of the independent equations that we can write. In other words, this is the condition for statical determinacy. You remember, if we have more unknowns than the number of equations, the system would be statically indeterminate, and if we have fewer unknowns, then the system is likely unstable. So the number of unknowns for a truss are the number of the forces in the member, so the number of members basically, plus the 3 external reaction forces that we need to solve for. And how many equation forces we can write? Well, this is equal to the number of the joints times 2 equations that we can write for each joint. So if we satisfy this equation, then our truss will be statically determinate both internally and externally. And we can see how we can apply this equation in our truss that we analyzed in the previous lecture using the method of joints. So that was a Warren truss, like so, with some externally applied forces, but what is important is our unknowns, the 3 external reaction forces. So here, the number of members, if we count them, 1, 2, 3, 4, 5, 11 members in total. The number of joints, 1, 2, 3, 4, 5, 6, 7 joints. So that means 11 members plus 3 external reaction forces to determine equals to 7 joints times 2 equations per joint. So 14 equals 14. So in this case, the truss was statically or is statically determinate, and that's why we were able to solve for all the members in this truss. So again, this is the method in which or with which we can use to determine that a truss is statically determinate. The other concept that I would like to talk in this lecture is that of cantilever trusses. And you might remember that I mentioned about this in the previous lecture and the method of joints when we were solving for the external reaction forces. And what I said at that time is that you don't necessarily, in general, you don't have to solve for the external reaction forces for cantilever trusses. And the reason for that is these types of trusses, they have the reaction forces at one end only, and therefore you can start the analysis from the other end. So if the question does not specifically ask you to solve for the reaction forces, then you don't need to do so, and you start your analysis from the other end, from a given, a known, externally applied force. Okay, it's very important, especially in an exam, under exam conditions where time is limited. And if you can recognize the cantilever truss, then you don't have to waste time by solving for the external reaction forces. So let's look at a couple of examples of cantilever trusses to see what I mean by that. So this is one, and you can see it's a horizontal truss and both supports are at the left end. It's kind of like, say, the support of a canopy or a balcony, right, which is supported only at the left end. And say there's a force applied like so at E. And if we, for example, use the method of joints, one can easily realize that we can start from joint E at the right end of the truss and then continue on analysis with joint F and then joint D and so forth until we end up with joint A and finally joint J, right? So in the end, we have analyzed the truss from right to left, each joint sequentially, and we end up by determining all the member forces without knowing the reaction forces at A and J. Another type of cantilever truss is this one, say vertical. It could be a electricity transmission pole, for example, or some kind of other vertical structure supported at the bottom at the ground level, as you can see, by a pin and a roller at G and H, and with forces applied in this case at A, C, and D. So again, we don't have to start by solving for reaction forces at the bottom of this truss. We can start from the top, from joint A and then joint B and C and so forth, joint one by one sequentially, and the last joints to be analyzed will be H and finally G, and then again we finish solving for all the forces in the members of the truss without actually having to solve for the reaction forces at G, Gy, Gx, and at H, Hy. So we have saved some time by not solving for the reaction forces for these cantilever trusses. So it's very important to recognize these configurations and don't bother calculating the reaction forces for such cantilever trusses unless this is specifically required in the question. Then you would have to calculate the reaction forces. But if not, you don't have to do that. So remember this. It's very important because it saves you time in an exam. It saves you a lot of time. So thank you very much for watching this lecture. In the next one, we will learn about another important concept that will also save you time in an exam if you apply that concept